So hello everyone and welcome to these questions of GATE 2022, 2 marks organic chemistry questions. So let us check these questions. So in the first question we have been actually given a carbonyl reactant, and the first two steps consists of NaH2 equivalent, which is sodium hydride, which is a base, and methyl iodide 2 equivalent. So what this does is it actually replaces the two H's that are present adjacent to the carbonyl and the phenyl moiety, which are the acidic protons, by methyl, which is supplied by MEI. So these are the acidic H which are actually abstracted by the base, which is the NaH, and then the methyl iodide actually supplies the methyl and replaces them. So this step actually happens in subsequent reactions. So where in the first step one proton is actually abstracted by the H minus hydride and one equivalent of the NaH actually, and then methyl iodide actually forms, methyl iodide attacks basically after the formation of an enolate, and so then methyl iodide actually forms, and this attacks to form the first methyl substitution. After that, once again NaH and MEI with further subsequent steps and similar mechanism forms the another methyl substitution. So we get the dimethyl substitution over the two protons that are present there. After that, the NH2OH HCl hydroxylamine hydrochloride that has been provided to us actually attacks the carbonyl moiety, and that causes the NH2OH to slowly react with that. After that, proton exchange happens, and finally we get like there is a hydroxyl group and there is an NHOH group present there, which then the HCl present with the hydroxylamine actually causes it to get protonated, and ultimately as you can see that water is eliminated to form the double bond NOH or double bond NOH group. So as we can see that this type of functional group is actually present in the Beckmann rearrangement reaction, where the rearrangement can occur, but also if another acidic H is present, as such is present here, and if the leaving group, that is the OH, is very good leaving group, which is converted by BCl5, so it becomes Cl, it is a better leaving group than OH. So then also cyanide bond formation can happen. So C triple bond N can also form by the transfer of the bond. So then so this type of Beckmann rearrangement type reaction happens here. The mechanism is Beckmann rearrangement type, and what we get here is that there is this two methyl groups, and that center becomes a carbocation, and we also get a C triple bond N. Now in the carbocation center, elimination happens, and this elimination actually gives rise to the olefin that is present. So then finally we get this product as the answer of this question. Yeah. So thank you for listening to this. Okay, and as you know that this Beckmann rearrangement that is happening, the driving force being the formation of the C triple bond N bond. The C triple bond N is very strong bond in the cyanide or the nitrile. Okay, so going to the second question, let us see. So we have been given a dieno file actually. So we have been given a diene, and here we have a big compound, but ultimately I hope that it will change into a diene type of sorts, or at least two centers which can actually react via Diels-Eller type of mechanism. So as we can see, we have got SiMe3, we have got OCOCF3 in the two ends of this compound, and we have been given zinc chloride. So as we know that zinc has got an high affinity towards oxygen, and hence due to that high of affinity, the carbonyl of OCOCF3 actually ultimately gives to ZnCl2, and overall the CF3CO minus group actually leaves, being a better leaving group. So then what we get is that there is a positive charge in the 2-methyl center. So there is a carbocation which is generated and which is stabilized due to the presence of two alkyl groups on that particular carbon. And all this happens due to the high affinity of zinc and oxygen. So if that not was the case, then there was already a double bond CH2 present which could have reacted. Okay, so now the Cl minus that is present in the zinc chloride actually coordinates with the silicon, and Me3SiCl or TMSCl leaves, giving us a negative charge on the other carbon. So we have got a positive charge and a negative charge, and we also have this diene present with us. And due to the presence of this negative and positive and the diene, we can have a Diels-Eller type of addition reaction, and this type of addition reaction ultimately gives us or yields the product that we are thinking about, and ultimately we get this product as the answer to this question. So these are the two questions, and follow the part 2 video for more mechanisms and more solutions of GATE 2022. So thank you, and keep practicing and write organic chemistry reactions.